A quadratic equation is nothing but a mathematical equation with one variable, but the highest power not 1 but 2. So any equation which is in the standard form written like ax square plus bx plus c is equal to 0 can be called as quadratic equation. In this equation, a, b, and c are coefficient of x square, coefficient of x, and constant term respectively. So equation which in standard form can be written as ax square plus bx plus c is equals to 0 can be called as a quadratic equation. Okay. There are additional rules which we need to understand that a cannot be equal to 0 no matter what. So if in a quadratic equation a value is 0, then it is not a quadratic equation. B and C has no such restriction. So B and C can be any real value. So it can be positive real values, negative real values, fraction real values. These values can also be in square roots. Okay, for example, if we have equation like this, 0x square plus 5x plus 6 is equals to 0. Is this a quadratic equation? No. It will become 0. So the final equation you are left with is 5x plus 6 is equals to 0, which is a linear equation and not a quadratic equation. Okay, this is linear equation, not a quadratic equation. So coefficient of x squared cannot be 0. A cannot be 0. That's compulsory. Okay, there is no restriction on B and C. B can or C can be 0. For example, if I write an equation like this, 5x squared plus 6. Is this a quadratic equation? 5x squared plus 6? Yes, it is. It is.
No, but then like it should be like bx, right? Like bx.
Yes, that's what I said. B and C can be any real value. It can be positive, negative, 0. There is no restriction on B and C.
So, but then there is no c, or like there's only b, like there are only two terms, and then there is equal to 0.
No, we have actually a term, ax squared, which is 5x squared. So a is fine. We don't have the x term.
So it's not a quadratic.
It is a quadratic equation. Quadratic equation, like compulsory that x squared term is there. X term is there or not doesn't matter. It can still be a quadratic equation. Clear? I hope that makes sense.
Yes, sir.
Yes. What about this? 5x squared plus 7x is equals to 0. Is this a quadratic equation? Yes, it is a quadratic equation because a is there, b is there, c is 0. C is not there, c is 0. Correct? Am I clear?
Yes, sir. Yes, sir.
Okay. How about this? X plus 1 by x is equal to 5. Is this a quadratic equation? Now here at this stage, it doesn't look like a quadratic equation. But if we reshuffle the terms and try to write this in standard form, okay, we can proceed by first taking LCM on the left side. So this is x squared plus 1 divided by x is equals to 5. So this is x squared plus 1 is equals to 5x. Now x squared minus 5x plus 1 is equals to 0. Now can I say this is a quadratic equation? Yes, it is a quadratic equation. So equation which are not written in its standard form, like doesn't look like in a quadratic equation from its initial presentation, needs to be rearranged, reshuffled, and brought to a standard form for checking whether it's a quadratic equation or not. What do we have equation like this? X square plus 5x plus x into 1 minus x is equals to 0. Is this a quadratic equation?
Yes, sir.
Let's try to simplify because this is not given in the standard form. So we'll simplify it to term x squared plus 5x plus x minus x squared. Okay, when you expand the bracket in the third term, we get x minus x squared is equals to 0. Now if you observe carefully, x squared and x squared get cancelled. So we are only left with 5x plus x 6x is equals to 0. Is this a quadratic equation? No. So it's not a quadratic equation. Okay. So it's not that if you see a x squared term, you can be sure that it is a quadratic equation. You need to further simplify and check if the x squared term remains on in the final step after simplification. If it is getting cancelled, then it doesn't qualify to be a quadratic equation. Clear? Variable. Okay, linear equation in one variable are equations where the highest power of x is 1. Okay, so linear equation in one variable could be equations like this. X plus 5 is equals to 0 or is equals to 6. So this is linear equation in one variable. Solving this, we can say x is equals to 1. So x is equals to 1 is one solution which satisfies this linear equation. Okay. No matter how complex the linear equation is or it looks like, it only has one solution. There's only one value of x which is satisfying this equation. What is that value of x? Simplifying it using the properties. So we take 2 to the other side. So we get 5x plus 5 is equals to 2. Then we shift 5 to the other side as a minus 5. So this becomes 2 minus 5 minus 3. And therefore x is equals to minus 3 by 5. So linear equation in one variable has maximum one value of x or whichever variable is given in the equation, which is satisfying that linear equation. But that's not the case with quadratic equation. Quadratic equation can have maximum two such values which can actually satisfy a given quadratic equation. For example, if I take this quadratic equation, x squared plus 5x plus 6. Okay, so I would like you to try x is equals to minus 3. Okay, I like you to try with x is equals to minus 3. So substitute x value as minus 3 in this equation and see if you get the answer as 0. Yes,
It's 0.
it is 0.
Yes.
So when I put x value as minus 3, like minus 3 square plus 5 into minus 3, okay, plus 6. Minus 3 square is 9. 5 into minus 3 is minus 15 plus 6. Okay, we add the positive term. 9 plus 6 is 15. Minus 15 is 0. Okay, can you please try with x is equals to minus 2? Do
Then 0.
it is still 0.
So
So what we therefore understand that there are two such values of x which is satisfying this quadratic equation, and therefore these values of x means x is equals to minus 3 and minus 2 are called as root of the quadratic equation, or they are also called as zeros of the quadratic equation. You can test with any value of x apart from these two values. I use minus 3 and minus 2 certainly because I knew that these are the roots. Okay, if you try with any other value like 1, 2, 3, 5, minus 2, minus 5, oh sorry, minus 2 is there, minus 1, minus 5, you will never again get a 0. It's only these two values which are giving 0. Therefore, these are roots of the quadratic equation. So roots of quadratic equations are nothing but the values of x for which the value of the quadratic equation gets satisfied, or it is equal to 0. Clear? Instead of root, we can also say solution of the quadratic equation. Okay. In this question, it's given that root of 2 by 3 is solution for that quadratic equation. Find the value of m. Okay, a quadratic equation can have two solutions. This is one of the solution. Just as we did in the previous case, if that is a solution, then the solution must satisfy the quadratic equation. That means if I replace x with root 2 by 3, it would be equal to 0. Okay, so that way you get one equation in terms of m. Simplify that to get the value of m. You understood what I'm trying to say here? So all I'm trying to say is, since this is a solution of that quadratic equation, I can replace x with this value and we'll get that is equal to 0. So let's try and do that. Okay, so in place of x, we can write root 2 divided by 3 whole square plus m multiplied with root 2 by 3 plus the 2 is equals to 0. Okay. What is square of root 2 by root 3? The root and the square get cancelled. So this is 2 divided by 3 plus m root 2 by 3. Okay. Plus the 2 is equals to 0. Okay. We can cancel this and this. Therefore, m times root 2 by 3 plus, now add these two numbers, 2 plus 2, 4, plus 4 is equals to 0. Okay, we can simplify further by taking 4 to the other side and then cross multiplication. So m into root 2 by root 3 again is equal to minus 4. Okay, therefore m is equals to minus 4 root 3 divided by root 2. Okay, you can rationalize by multiplying up and down with root 2 because there's a root sign in the denominator, right? So we can rationalize by multiplying with root 2 in the numerator and the denominator. So we get minus 4 root 3 into root 2 is nothing but root 6. And in denominator, we get root 2 into root 2, that's 2. Now we can cancel this 2 with this 4 2 times. Therefore, final answer is minus 2 root 6. Clear? That is value for m. So this question says 2 by 3 and 1 are solutions of quadratic equation mx squared plus nx plus 6 is equals to 0. Find the value of m and n. Okay, so both 2 by 3 and 1 are solution of quadratic equation mx squared plus nx plus 6 is equals to 0. Find the value of m and n. Okay, so what we do in this question, I think we can start by substituting x value as 2 by 3 once and then x value as 1 like in the second attempt and try and get two equations in terms of m and n because we don't know value of m and n. So technically we'll end up getting two equations in terms of m and n, which would be like two simultaneous linear equation in terms of m and n. Simplifying that either by using the method of substitution or elimination, we can find the value of m and n. Let's just get started. So first we'll substitute x value as 2 by 3 as I said and try to form this first linear equation in two variable. So m times 2 by 3 square. Okay, let's write that directly 4 by 9 plus n times again 2 by 3 plus a 6 is equals to 0. Okay, let's simplify by taking LCM. So first term 4m by 9. Okay, I can see LCM is 9 only, right? So I can just multiply here only with 3 and 3 and here with 9 and 9. So I'm trying to take LCM in the first step itself. So this is 4m plus 6n plus 54 divided by 9 equals to 0. Now if you want, you can take 9 to the other side and multiply with 0. Multiplying with 0 will make difference and we'll get final linear equation into variable as 4m plus 6n plus 54 is equals to 0. Okay, in most of the cases we used to write this on the other side. That also we can do in the next step if required. So we'll just leave it like this for now. This is my first equation. 4m plus 6n plus 54 is equals to 0. Okay, we got one equation. Now we need to form the second equation. So we do the same thing what we did with the first value, but now this time I'm going to substitute x value as 1. Okay, therefore m into 1 square plus n into 1 plus 6 is equals to 0. That means m plus n plus 6 is equals to 0. This is equation 2. Okay, so these are two equations, equation 1 and equation 2. We can simplify these using the method of elimination or substitution. I think elimination is what we are more comfortable with. So let's use elimination. Okay, we write the first equation again, 4m plus 6n. Okay, okay, let's take 54 to the other side and write it as minus 54. Next equation. See here, both m and n number is 1. Okay, so maybe before copying it on the other side, if we can multiply it here itself by some number, what do we multiply it with? Let's do minus 4. And even here now, let's not change because if we do make too many changes in the same step, there might be chances of making silly error. So we'll leave 54 on the same side and equate it to 0. This is my first equation. Second equation, let's multiply with minus 4 and then carry it to the other side so that m gets eliminated in the next step. So this is minus 4m minus 4n minus 24 is equals to 0. Okay,
Yes.
this gets cancelled. 6n minus 4n is 2n. 54 minus 24 is 30. So 2n is equals to minus 30. And n is equals to minus 30 divided by 2. So minus 15. Okay. Now we can replace n with this value in one of the equation, whichever you like. I think let's use this equation. M plus n plus 6 is equals to 0. So n is minus 15. So minus 15 plus 6 is equals to 0. Okay. Minus 15 plus 6 is minus 9 is equals to 0. M is equals to 9. Here. So here we go. This is the question. If 3 and minus 3 are solutions of the equation ax squared plus bx minus 9 is equals to 0, find the value of a and b.
Yeah. I again went wrong.
See, we
Yeah,
just
B is 0.
we first put a value as, let's say, 3. Sorry, x value as 3. So it is a into 3 square, which means a into 9. So 9a I can write. Okay, then b into 3. So we can write 3b. Minus 9 is equals to 0.
So for easier calculation, can we take 9 that side? It's more better and easier.
Yeah, you can.
Okay. And then since like all 3 are divisible by 3, it'll become 3a plus b is equal to 3.
Okay, so you mean let's divide the entire equation by 3. That also sounds like a good step. So
Yeah,
3,
and I went wrong in dividing that 9s. That's why I got the wrong.
so this is equation 1. So you can divide the entire equation by 9. That makes our equation
In
with.
equation 2, it's 3a minus b is equal to 3.
Okay, so in equation 2, we put x value as minus 3. So again, the first term would be a into minus 3 square plus b into minus 3. Okay, minus 9 is equals to 0. Okay, let's simplify this. Whether it is plus 3 or minus 3, square is always positive. Okay, so the first term would become 9a minus 3b. Okay, and we can take this 9 to the other side and write it as 9. Clear?
Then we divide that also.
Then we can divide this also. So 3a minus b is equals to 3. This becomes our equation 2. Okay, I can clearly see that in equation 1, we have a plus b, and in equation 2, we have a minus b. Therefore, we can just write the equation like that without multiplying or dividing. So let's write 3a plus b is equal to 3, and also 3a minus b is equals to 3. Okay, let's add the two equation. Minus b and plus b get cancelled. 3a plus 6, 3a is 6a is equals to 3 plus 3, 6. So a is equals to 1. Substituting this back in any other equation, maybe this. Okay, 3 into 1 plus b is equals to 3. Okay, therefore, okay, b is equals to 3, and this goes 3. This 3 goes to the other side, becomes minus 3. So 3 minus 3, 0. Maybe you can just
So can
tell me if this equation you see there is a quadratic equation or not.
no, sir.
It's not a quadratic equation.
No, sir. So x square and x square will get cancelled.
Yes. Yeah. So finally, in the final step, we don't have x square, right?
No, sir.
Because the x square gets cancelled. So this is not a quadratic equation. Okay. If we simplify this, no, x square plus 5x minus 5 on this side. On the other side, we expand using the property a minus b whole square. So a square plus b square and minus 2ab. So minus 6x. Okay, we can clearly see the x square gets cancelled. Either you can bring it to this side and cancel, or you can just cancel it like this. So therefore, not a quadratic, as we don't have the x squared term. Okay, you can simplify the rest of the equation, but we can tell even at this stage from observation that we can't have a x squared term anymore, like after this cancellation. If x is equals to 2 and x is equals to 3 are root of the quadratic equation, find the value of m and n. What is your answer?
I got, okay, I got n as 9
M as 9.
N is 9.
Okay.
And M as 7.5.
7.5. Okay. What is your answer, Nishika?
So n is 9, m is 15/2.
Which is 7.5.
Yeah.
15/2 is 7.5. Okay. So this is the answer, right? I hope that's fine.
Yes. Yes.
Yes.
Is it okay that I gave it in fraction form and not in decimal?
That's okay.
Yeah.
Okay. So the next important topic in this chapter is nature of roots. How do we determine nature of roots? Okay. It's important that we understand what root means and what we mean by nature of roots. Now, if you remember in the beginning, I gave you an example of a quadratic equation. X squared plus 5x plus 6 is equals to 0. And then I asked you to test with two values of x, which means x is minus 3 and minus 2. And for both these cases, when you checked, you got the whole thing as 0. Means this condition got satisfied. Okay. Therefore, this quadratic equation has two roots. Okay. Or you can say two real roots. Am I clear?
Yes.
But there are some other quadratic equations which, when you simplify, okay, in this case, if you check, there's only one value of x, which is x is equals to minus 2, which is satisfying this equation. You can try with all possible values and you'll never find another value. Only x is equals to minus 2 is satisfying the equation. So we say this has one real root. Okay. One real root means, see, generally we say, like generally in general talking, we say quadratic equation can have two roots. Okay, we will call them as alpha and beta. So we generally say quadratic equation has two roots, alpha and beta. Okay, if alpha and beta has different values, then we say two real roots. For example, here alpha is, let's say, minus 3 and beta is minus 2. So it has two real roots, means alpha and beta has two different values. But in this case, in the second equation, there's only one value of x which is satisfying this quadratic equation. Okay, so either we can say that it has one real root, or we can say that both alpha and beta is minus 2. Okay, means it has roots are equal, so equal roots. Both this means the same, like whether I say one real root or I say equal roots, it means the same. One real root means there's only one value of x which is satisfying this equation. Okay, when I say equal root, it means both alpha and beta are minus 2. Therefore, it has only one root technically, because both alpha and beta are the same. You understand my point? So please don't get confused with this. Whether we say one real root or equal root, it means the same. Clear? And again, you can have quadratic equations like this. You can try your best. Okay, you can try your best, try all possible cases. Okay, like try all possible values which you know in this equation, but you will never get a value of x for which this is true. So you will never be able to find a fraction, a decimal, a root value, any value of x which is going to satisfy this equation. So this equation falls in the category where we say there is no real root or no roots. Am I clear?
Yes.
So what we need to understand in terms of quadratic equation is, it's not that every quadratic equation has two roots. Some quadratic equation can also have one root or both the roots are same. So one real root. Plus there are quadratic equation which has no roots. Okay. Now, so how do you know this? Just by looking at the equation. Discriminant test says that for a quadratic equation, try to find the value of its discriminant. Now, what is discriminant? Discriminant is equal to b square minus 4ac. Okay, what is 4a and c? B, a, and c. These are just the coefficient of x square, x, and the constant term in the standard form. So this test says that first you find value of a, b, and c after organizing your quadratic equation in the standard form, which you write it like this. Even if it's given in some other form, first write it like this. Write it as ax square plus bx plus c. Then from that, uh, through comparison, determine the value of A, B, and C. Okay, find A, B, and C value. Then plug these value in this formula, find the value of D, the discriminant. Okay. Now, based on the value of discriminant, you can decide or you can predict whether the equation will have two root, one root, or no root. If discriminant value is greater than 0, then it has two different roots. If discriminant is equal to 0, then it has only one root. And if discriminant is less than 0, then it has no real root. Am I clear? So if the discriminant is greater than 0, then probably you'll get two values of x which will satisfy the equation. If discriminant is equal to 2, then only one real value will satisfy the equation. And if discriminant is less than 0, then no values of x would satisfy the equation. Am I clear?
Yes, sir.
All right.
Yes, sir.
Let's go behind first case discriminant b square minus 4ac. That's what we're trying to find here. So b square, b is 5, so 5 square 25 minus 4 into
A is 1.
and
C
three
is
is 6. So 25 minus 4 6 are 20. Okay, one is greater than 0. It's positive, right?
Yeah.
So d is greater than 0. That means two real roots. Okay, this one here, one real root. Okay, let's find discriminant. 4 square is 16 minus 4 into 1 into 4. So 16 minus 16 is 0.
0.
So d is equals to 0. So equal root. Well, in this last case, 2 square is 4 minus
4 into 60.
4 into 16 or 16 to 4. So it is 4 minus 60, 4 minus 60.
Yes.
So d is less than 0. That means no real root. Okay. You can try and check if you are interested. You will never be able to find a value of x where this equation becomes 0. It's not possible. Clear?
Yes.
So one learning which we had from this in this concept is it is not always that quadratic equation has two roots. 2 is the maximum number you can have. It can also have one root or no root. Clear?
Yes, sir.
But you will find many questions where they will ask you determine the value of p or m for which the equation has equal roots. Okay, so we'll see that in the next class. I think for today it's enough. Okay, see you then. Thank you and bye everyone.
Bye.
Nice.